joint presentation. And I'd like to introduce Dana Mitchell. Dana Mitchell is with American Governor. Dana Mitchell is with American Governor. She joined them in 2012 after earning an environmental studies degree from Temple University. She's currently a project administrator and is working towards becoming certified as an assistant project manager. So good luck for that. And joining her is Paul Brumley. Paul is a senior system engineer with TVA, specializing in hydraulic control systems with over 12 years experience. Member of Chattanooga, Tennessee ITT Tech School Electronic Advisory Committee, and an engineering degree from the University of Tennessee, Chattanooga. Tennessee, Chattanooga. Please welcome them as they talk about oil, I think.
I want to start out by telling you I've been in your shoes before. It's the last go around before lunch, and I know that probably it's less important what we say than how long it takes me to say it. But I think we have something interesting for you. I have to tell you, first of all, anything that I say here today is me and not TVA, okay? It's the standard disclaimer. I want to talk for just a minute about TVA, and then after that we'll get into all of these subjects and the really hard stuff Dana is going to cover, okay? The TVA, of course, is a federal agency. It was founded in 1933, part of the New Deal. Some of you in here, I hope know this already, but some of you may not. It's a corporate agency of the United States. We receive no appropriated tax dollars. Everything we do, from buying coal to keeping the picnic tables in good repair and the grass cut, comes from power sales. And our operating revenue is almost $11 billion annually. We have 9 million people in 7 states, which you can see there. I'm going to do it off the top of my head. Parts of Kentucky, Virginia, North Carolina, Georgia, Alabama, Mississippi, and almost all of Tennessee, including where we are right now in Nashville. We have 49 dams. All of them are for flood control, but 29 of them create electricity. This is a map of our service area, and you can see, I don't have a "You Are Here" button, but you can see Nashville up there, and the dark green is our service area. Not all of which is in the Tennessee Valley proper, but anyway, that's our service area. The red, I guess you'd call those dots, the red indicators are our the dams. And like I say, 29 of those are for power. We're not worried about those other plants. We're just worried about the hydro. You can see we go from the top right, which is Bristol, Tennessee, Virginia, and all the way down through Chattanooga, through Alabama, and then back up to Paducah, Kentucky. So it's a long way. Here again, 29 hydro plants, 1 pump storage. We have 3 nuclear plants, 11 coal plants, 9 combustion turbines, and you can see we basically have a little bit of everything. Net summer capability, a little over 37,000 megawatts, and 16,000 miles of transmission lines, and the transmission line people would want me to say they are 99.99% reliable. And if you want some more information, you can go to either tva.com or .gov. It's the same site. And now I'm going to turn it over to Dana.
Hello. So I'm going to talk briefly about the early mechanical governors. These were oil-free systems, and this particular governor that's shown is a belt-driven flyball governor. It is the Woodward size D, and it was manufactured, I believe, in 1901. These governors use minimal oil, which was added occasionally to the moving components. And for the turbines, the wood from the lignum vitae tree was used as self-lubricating bearings. So a little bit of a background in governor oil. There are 3 base oil types. First being the paraffinic, which is your engine oils, hydraulic fluids, and turbine oils. Next is a naphthenic, which would be your transformer oils. This would be your dashpot oil, and it's also used for metalworking. And finally, aromatics, which are used in rubber processing and plasticizers. The paraffinic subgroups, there's 2 of them. Group 1, which is solvent refined. This is how oil was traditionally refined. And Group 2, which is hydrocracked and iso-dewaxed. This process improves the viscosity. It results in a lighter color, a lower volatility, and better oxidation stability. Group 2 oils have a lower solvency characteristics and require additional chemicals to bind it chemically. So early on, oils were not labeled as Group 1 or Group 2 by the manufacturers. Operators began noticing the buildup of sludge and varnish within the sump, and this eventually would get into the internal governor components and bearings. The system would then need to be flushed, and the oil would need to be replaced. It turned out the early Group 1 and Group 2 oils could not be mixed. And it wasn't because the oils were not compatible, it was because of the additives that were in the oils. Mixing them would cause additive dropout and the buildup of the sludge. One of the additives that would drop out was the anti-foam. This would result in air entrainment and cause it to become a non-compressible liquid, and that adiabatic action would create carbon buildup in the filters. As little as 2% of a Group 1 oil could cause this additive dropout. So this problem went undiagnosed for about 4 years before being resolved. So current Group 2 oils can be mixed with Group 1 oils without having this sludge buildup. So next I'll talk about some iso viscosity grades. Oil is measured by its kinematic viscosity, so its resistance to flow and shear at 40 degrees Celsius, which is 100 degrees Fahrenheit. It's also could be measured by the centistroke, so 1 centistroke is equivalent to 1 millimeter squared per second of movement. The iso viscosity classifications, there's 20 grades, and up on the screen you can see 3 of them. They range from kerosene to cylinder oils, and the grading allows for a 10% tolerance on either side of the nominal range. The iso system is the same for turbine and hydraulic oils, but turbine and hydraulic oils cannot be mixed. You can use a heavier grade oil, but it's dependent on your system requirements. So for biodegradable oils, these can be plant-based or synthetic. They are typically less toxic than traditional oils. They have the ability to break down quickly and safely by biological means. Bio-oils are polar in nature, and they require reduced quantities of anti-wear agents, which makes them less toxic. They are available in a number of iso viscosity grades, and they can meet the same performance standards as conventional oils. They have inherently good lubricity and high viscosity indices, but they do require close monitoring and additional testing to make sure that they're not breaking down with use. They are susceptible to foreign materials and water entrainment, and this could cause changes in the viscosity. With bio-oils, the cleanup and reporting is the same as traditional oils. So by using bio-oils, it doesn't get you out of any environmental reports that you would have to do or make it easier to clean up spills. And to the layman, if they see it on the water, it's going to look like an oil sheen as a traditional oil. So next, we have some images of oil contamination. This was from a plant that one of our field service rangers, Chris Kreider, was at. He went to work on a unit and was having problems with cavitation. So he pulled the cover off the sump, and this is what he saw, a yellow, foamy, soupy mixture. This next picture to the right, if you look at the swipe of his finger, that gray is metal. That was a magnet that was in the sump to collect any shavings that may occur. In the bottom two pictures, you can see that the color is probably not what you would want your governor oil to look like. And that substance down at the bottom is where the additives have precipitated out of the oil. This was because the oil that was delivered to site was delivered in a tanker. The tanker the day before was carrying diesel oil. So it was probably not flushed properly, and the oil got contaminated. This resulted in the oil having to be changed, and the system had to be flushed. This is a great example of how new oil is not necessarily clean oil. Before you put oil in your governor system, it needs to be filtered, and you should also keep a sample aside for future testing and reference. Most of the problems within a governor can be traced back to the oil, and by maintaining clean governor oil, you can extend the life of the governing components and the oil itself. So one of the ways that you can maintain clean governor oil is through a kidney loop filtration system. These continuously filter oil from the sump and operate independently from the governor. So oil is pulled from the bottom corner of the sump. It's put through the filters, which the micron would depend on whether you're filtering for a digital or mechanical system. Once it's filtered, it deposits the oil in the opposite top corner of the sump, and this creates circulation, allowing all the oil to be filtered. And these systems can, as I said earlier, run continuously. The kidney loop filtration system can really serve as the canary in the coal mine for your governor's health. So with that, I am going to turn it back over to Paul so he can tell you some more war stories about some of the things he's seen. Paul?
These, I don't know where she got that idea. These are not my photographs, but this is some examples of what you're going to look for when you change your oil filters. On the right, we have she called that high oil contamination. You're looking for dirt or carbon or paint flakes, or if it's really bad, you see on the left there, we have metal. So you may have to get your metallurgist to tell you to look at your metal. He can tell whether it's the different kinds of wear, fatigue, or sliding, or cutting. And then you can tell by the type of wear where the metal is coming from. So in other words, if you suspect it's a bearing, it may be time to change your bearings. Or if it's part of a seal, an oil seal, you may have a leak in your future. This is just an example. This is the old style oil filter for the governor oil pump pilot valve. And I just wanted to show you this. This is the old kind, and this is the new kind we put in. That's what we're doing within our agency, putting in these new oil filters and 25 micron filters, and they're throwaway. These kinds, you take it and then rinse them out and reuse them again, and that's okay for a few years, but probably not 70 years, okay? But these are good until they get clogged. So it depends on your oil. If you have a good Kadon filtration system, these will last for a long time. EPA is in the process of slowly putting these kidney loop oil filtration systems on all of our governor sumps. We had a certain power plant where we had these installed, and I had gone down for a governor inspection. And when I got through, I went and talked to the foreman. This is a true story. I went and talked to the foreman. I said, Mr. Foreman, I've noticed you've got all your kitty loop filtration systems installed on your governor sumps. I said, that's excellent, because there was a lot of engineering work and a lot of implementation work I know that went into having those. And as the governor, man, I'm very proud that you have those, but I noticed none of them are running. And I said, why? Is there a problem? Why aren't they running? He said, Paul, if I turn them things on, all they do is clog the filters, and we got to go change the filters. I just want to talk briefly about the environmental protection in the plant. Obviously, oil spills are something that nobody wants. This is a picture on the right. This is at one of our plants. This is sitting right outside of the governor. The spill response kit. In that, you're going to have some oil soak pads. You're going to have coveralls, safety goggles, oil-resistant gloves for the crew that's going to clean the oil up. The reason for that is you've got to get the oil where it spills, because if it gets to the drains, depending on the age of the plant, it's going to drain either to your station sump, or in the really old plants, the drains go straight to the river. So you need this handy so you can clean up as soon as possible. On the left, that's a picture of an oil purification room. You can see we got a big can of, what do you call those? The oil absorbent rags there, right outside. I'm sure there's one inside, but what I wanted to show you here, you've all got it in your power plants, I'm sure. The bottom of that door is a little step that's painted yellow. That's just containment. In case there's an oil spill inside the room, you guys probably, most of you know that. It keeps the oil in the room and out of the drains. And here's actually two examples of, safety. The first one is pretty clear. It's the containment that the drums are in. These drums are obviously transporting oil. And the second one is the label that you can see on that the front left drum is the turbine oil 68. So you know what's in the drum. Here is our contact information, Dana Mitchell and me. Visit them and visit us.
Does anybody have any questions? Yes?
You talked about filtering your oil when you have your oil delivery.
Yes.
The tanker, so you filter it from the tanker before you put it into your governor?
Yes, you would run it either through a filter press, or you could run it through the kidney loop filtration system. But you do want to filter it before it goes in, otherwise, it's going to contaminate the system.
Is there a way to test the oil prior to?
Yes.
Do you do that too?
Yes. And I did that. I don't know if Dana mentioned. It's sometimes a good idea after you've got your oil filtered and you put it into your governor, take a sample of it so you have a sample of good, clean oil for comparison later. You can just keep that on the shelf and use it for comparison later. And did that answer your question? Checking. At TVA, we check our governor oil quarterly. We sample it, send it off to the lab, and they can tell you what's in it, etc.
And another easy way to test it is just having that original sample. You can look at the color, if the color's off, also the smell. And another way to test it would be to shake it. If you shake it up and it has a lot of air bubbles in it, that usually means that your anti-foaming agent has dropped out. So it's usually going to require either additional additives to be put in or maybe even to be replaced. Anybody else? Okay.
Thank you.